Cubis high-capacity microbalances from Sartorius. Lab operator Nick takes care of a wide variety of tasks at his laboratory. One of them is making calibration standards for HPLC. For this, Nick uses a standard microbalance to weigh samples. Unfortunately, its capacity is too low to weigh samples directly in the larger flasks used to prepare solutions. This means Nick must weigh tiny quantities of samples in weigh boats before transferring them into the solution. This reduces accuracy, as traces of the samples often get lost as residue that clings to the boats. Recently, however, lab manager Claire announced that she was investing in a high-capacity microbalance from Sartorius. This cutting-edge technology enables the accurate weighing of small samples directly in large volumetric flasks, thus eliminating the need for weigh boats and paper. With full-resolution 1 microgram readability, Sartorius high-capacity microbalances have set a new record in accuracy. However, weighing such small samples in large-volume vessels presents a number of challenges. The good news is that there's a careful process to follow to achieve this in a regular laboratory. To achieve optimal weighing performance, Nick firstly needs to pick the perfect place to set up his balance. On a solid stone table against a wall, or in the corner of a quiet, vibration-free laboratory. It should not be in sunlight or near to heaters or drafts. The climate in the lab itself should be kept constant. Temperature spikes and changes should be avoided. Humidity should also be kept constant and not below 40% to prevent electrostatic interference. There should be no cold air current from air conditioners nor machines, or engines nearby that generate vibrations or magnetism. Next, the balance must be correctly leveled and calibrated. Sartorius high-capacity microbalances support isocal adjustment and leveling with the Q-level function. This function levels the balance horizontally in each direction, ensuring accuracy. In addition, Nick should routinely check the balance using an external certified weight. During the measuring sequence, weighing vessels should be acclimatized to the same environment as the balance. Nick should not touch the container itself. A single fingerprint can weigh up to 50 micrograms. He should also avoid putting his hand inside the draft shield, as it may change the temperature inside, and should open only one door just as far as necessary. Next, Nick can place the tare container gently on the weighing pan or in the sample holder, tare and weigh in the powder. It's vital that no powder falls onto the pan next to the vessel. This will result in the displayed weight being different to the weight in the vessel itself. Finally, Nick should make sure that he doesn't lean on or apply pressure to the weighing table during the process. By carefully following these steps, Nick will ensure he gets the best possible results every time. Nick's happy with the new workflow, and manager Claire is even happier that she invested in a Sartorius Cubis high-capacity microbalance. It saves time, money, and ensures maximum efficiency and accuracy. For more detailed information and instructions about how to achieve optimal results from Sartorius Cubis, please visit our website.